Hey guys, Mr. Martella coming to you from home today and trying to get this super volcano thing started. So, what I decided to do, since I'm going to be here for the next few days and you're going to be there, I'm going to provide you with your background information for each scene that you're going to view through screencasts. All right. So, what you're going to do today is you'll be watching this screencast. I'm going to help you to answer your video background questions on your supervolcano video guide for scenes 1.1 through 1.2, which is due today. All right. So, for today, what you're going to need to do, once again, is watch this video, all right? I'm going to help you to answer the background questions, and then you're going to have to go to the Supervolcano movie. I've posted a portion of it from YouTube, and you'll have to watch about the first 20 minutes of it to answer the questions that you need to answer in the Supervolcano video guide so that you can turn that in before midnight tonight, okay? I also want to let you guys know that I have posted a Zoom link to each class. And if you guys have any questions while you're in science class today, you can just click that link and speak live with me. I'll be here just waiting to help you. Okay? So let's get into these video questions so that you guys can get started and turn in your work today. All right, the first, actually, I think this is number 2 on your paper, so my numbering might be a little bit off here. Don't worry about it. The question is, what are supervolcanoes? And you should really be able to answer this without me at this point. We spent a couple of days reading about them. So technically, supervolcanoes describe a volcanic center that has had an eruption of magnitude 8 on the Volcanic Explosivity Index, or the VEI scale, meaning that the measured deposits for that eruption is greater than 1,000 cubic kilometers. So remember, folks, supervolcanoes can have eruptions that are less than super, all right? The only criteria that they need to meet to qualify as a supervolcano is they must have had at least one eruption of 1,000 cubic kilometers or more in the past. So one VEI8 eruption, all right? You can see in the fine print at the bottom there, I just included some of the other supervolcanoes around the planet. If you think back to the short video that we watched in class the other day, there are about 20 of them worldwide, okay? So that's that question. Now, the next question on your paper is, what is the USGS and what do they do? The United States Geological Survey, that's what the USGS is. And it's a federal agency that monitors and provides scientific information about natural resource conditions and issues. The USGS has offices in all 50 states. The nearest one for us would be in Pittsburgh. So in the movie, the main character is the scientist in charge of the Yellowstone Volcano Observatory, or the YVO, and his name is Rick Lieberman, all right? So Rick Lieberman is not a real person, but that job is based on a real person. There is an actual head scientist. His name is Dr. Michael Pollan, okay? I think we talked about that a little bit yesterday in class. But for the movie, main character, Richard Lieberman, okay? So what does the volcano look like at Yellowstone? That's your next question. Well, and I know that I've drawn this on the board in class several days. Yellowstone, if you're looking for that tall, pristine, iconic, cone-shaped volcano, you're not going to find it, okay? It's on another scale, a different scale. Yellowstone doesn't look like your typical cone-shaped volcano. It is what we call a hidden caldera, or a restless caldera volcano. And the crater is so vast that it provided aerial pictures of the park in the 1980s. For years, scientists walked around Yellowstone. They knew it was volcanic and they could not find the volcano. It's because, as I said before, they were looking on the wrong scale. All right. If you're at Yellowstone, you're most places you're in the volcano. Okay. So you need to see it from far away in order to get a view of the whole thing from the air, from space. Okay. And that's what these hidden caldera or restless caldera volcanoes look like. Now, I just want to quickly show you this USGS video where Dr. Dina, I believe her name is, creates a little caldera. And this represents, on a small scale, what happens on a much larger scale after supervolcanic explosions.
Hi, I'm Dr. Dina. I work with the U.S. Geological Survey in Menlo Park, California, with the Volcano Hazards Program. Today we're going to talk about calderas. When most people think about volcanoes, they think of a triangle shape, and that's what many volcanoes look like. But there are other shapes too, and one of those is called a caldera. What we've done is created a simple experiment to show how calderas form. The experiment uses flour, a piece of tubing with a balloon attached at the end, and a bicycle pump. So what I want you to imagine is that this is the surface of the Earth in an area that's volcanically active. Underneath the surface of the Earth, we're going to inject some magma. When we inject the magma using our handy bicycle pump, it's going to push the surface up. So let's watch. As you can see, the flour is being moved out of the way as we inflate the balloon or add magma to the system. The Volcano Hazards Program has monitoring equipment at different volcanoes to watch ground deformation such as this. In this case, what we're going to do is we're going to pretend that this large amount of magma erupts. To do that, I'm going to let the air out of the balloon, and then we're going to watch to see what happens. So as the air comes out of the balloon, you want to imagine the magma escaping from the magma chamber. Once the magma leaves the magma chamber, there's nothing to hold up the overlying rock. And so all that rock collapses down to where the chamber used to be. So you can see in our experiment, the flour has now collapsed in a somewhat circular shape. We call this shape a caldera.
All right, thank you, Dr. Dina. And that's how calderas form. Okay? So, what does hydrothermal mean is your next question on your video guide. And hydrothermal refers to features that relate to water that has been heated by magma deep underground. So, Yellowstone has hot springs, mud spots, steam vents, and geysers. These are all hydrothermal features. And you will hear the word hydrothermal referenced in the movie quite a bit. All right, that's why I include it here. Okay? Question 5 asks, how big is the Yellowstone volcano? And I've gone over this. Remember, we've talked about other supervolcanoes on the planet. Toba, it's with its 22-mile by 60-mile caldera, and that's the largest on the planet. Yellowstone would come in a close second. The present caldera at Yellowstone is 30 miles from north to south and 50 miles from east to west. All right? So, just to get a sense of how big that is, if you drive from New Brighton to Pittsburgh, you will have traveled about 30 miles. Okay? So that's the distance in one direction from rim to rim of this caldera. And it's massive, obviously. Okay? Um, I believe you had one more. No, this might have been it. So, we've compared the volumes of eruptive material before. I've shown you this same data in a lot of different forms. Um, and you can see here, this one has, you see the eruptive material from Tambora. Remember, that was the year without a summer, 1815, 1816. Here we see Krakatoa's eruptive volume, Mount St. Helens down here. This is Yellowstone's biggest eruption. Okay, all three of these represent Yellowstone eruptions. All right, so we're learning about supervolcanoes. We're taking a close look at Yellowstone for good reason. All right, remember I told you yesterday there's no volcano closer to us. So I will post this to Schoology for you guys also so that you can remember. You need to watch from the very beginning up to about the 20-minute mark. I have written down 19 minutes, 49 seconds in the YouTube Supervolcano video. All right? And I will be back with you tomorrow to go over some more questions and help you out with any background information that we may need before watching more of the movie. So I hope you enjoy. And if you need anything, remember, you can reach me live on Zoom during your class today. Take care, guys, and we'll see you next time.